Welcome to Database Mart's GPU series. In this video, we'll be reviewing the NVIDIA RTX 5090 GPU server. For more in-depth test data, be sure to check out the link in the comments section. Let's first look at the configuration of the RTX 5090 GPU server. First, we tested two versions of Gemma 3. The first one was the 12 billion parameter version, with a model size of 8.1 gigabytes. The CPU usage rate was 6.9%, the memory usage rate was 2.8%, and the GPU utilization rate reached 53%. Under such resource consumption, it achieves an evaluation speed of 70.37 tokens per second and performs quite smoothly, indicating that in a medium-scale model, the RTX 5090 can achieve high inference efficiency with a relatively low system resource load. The second was 27 billion parameter version of Gemma 3, with the model size increased to 17 gigabytes. Correspondingly, the CPU usage rate slightly rose to 7%, the memory usage rate increased to 3.4%, and the GPU utilization rate rose to 66%. Although the resource usage has increased and the evaluation speed of this model has dropped to 47.33 tokens per second, it has not affected the performance, indicating that the RTX 5090 still has a strong throughput capacity for larger models. The third test was the 8 billion parameter Ollama 3.1. During the evaluation process, only 0.2% of the CPU usage rate was used, the memory usage rate was 3.5%, the GPU utilization rate was only 15%, and the inference speed reached 149.95 tokens per second. This means that with the support of RTX 5090, the 8 billion parameter version of Ollama 3.1 can achieve an extremely high throughput rate with extremely low resource consumption. The fourth test was the 14 billion parameter version of DeepSeek, R1, with a model size of 9 gigabytes. The CPU usage rate is 1%, the memory usage rate is 3.7%, and the GPU utilization rate has reached 65%. Indicating that this model has been able to fully mobilize the graphics card resources for computing. The evaluation speed is 89.13 tokens per second, demonstrating good balance and response capability. The fifth test was the 32 billion parameter version of DeepSeek, R1. The model size increased to 20 gigabytes, demonstrating higher hardware pressure and more complex computing requirements. The CPU usage rate rose to 1.7%, memory usage rate was 3.6%, and the GPU utilization rate reached 75%. Despite the significant expansion of the parameter scale of this model, its reasoning speed still remains at 45.51 tokens per second, demonstrating stable performance. The sixth test was the 14 billion parameter version of Qwen 2.5. The model size was 9 gigabytes. During operation, the CPU usage rate was 1.5%. The memory usage rate was 3.6%, and the GPU utilization rate was 68%. It achieved an evaluation speed of 89.93 tokens per second, with a very balanced performance. The seventh test was the 32 billion parameter version of Qwen 2.5. The model size was expanded to 20 gigabytes, the CPU usage rate was 1.4%, the memory usage rate was still controlled at 3.6%, but the GPU utilization rate was increased to 80%. Under this high-load operation state, its inference speed is 45.07 tokens per second, which is almost consistent with the model of the same scale of DeepSeek, R1. The last test was the 32 billion parameter version of QWQ. This model has a volume of 20 gigabytes. The CPU usage rate was 1.4%, and the memory usage rate was 3.1%. GPU utilization rate reached 88%. Under such high-load operation, an evaluation speed of 57.17 tokens per second was still achieved, which was superior to Qwen 2.5 and DeepSeek, R1, demonstrating excellent performance scheduling and inference efficiency. When NVIDIA RTX 5090 runs large language models under the Ollama framework, it demonstrates outstanding performance, especially when running models with 32 billion parameters or smaller in scale. Its high cost performance makes it an ideal alternative to H100 and A100, suitable for users who consider both performance and cost. Thanks for watching. If this video was helpful to you, don't forget to like, comment, and share. Follow us to learn more about servers.